prestigious researcher and postgraduate students of UiTM. First of all, I would like to welcome you to joining the Futuristic Research of Energy and Environment Free 2023. I'm Teh Chia, Coordinator of Energy and Environment, Research Nexus UiTM. It is my pleasure to be the moderator of program for today. We from ReNeU would like to thank you for time sharing with us today. For your information, this event is also live streaming at the NCPI YouTube. Before we move on, let us begin with the Lagu Negaraku and Wawasan Setiap Warga UiTM. I would like to request all guests of honors and attendees to stand up. Thank you, and please be seated. Next, we will have a recitation of Doa that will be led by Mr. Shakayum Nuraiman Hadis. Please, Mr. Kuyum.
Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala sayyidina Muhammad wa ala alihi washabihi ajmain. Ya Allah, Ya Karim, Ya Wadud. Kami memanjatkan kesyukuran kepadamu kerana mengizinkan kami untuk berada di dalam seminar Futuristic Research of Energy and Environment. Ya Allah, Ya Rahman, Ya Rahim. Kami memohon kepadamu agar engkau berkati majlis ini dengan limpah rahmat dan kurniamu. Semoga segala usaha kami mendapat keredaan dan hidayahmu. Rahmatilah warga UiTM yang menyumbang hikmat dan menambah bakti kepada universiti ini. Kami mengharapkan ihsanmu agar engkau teruskan dan lanjutkan kecemerlangan yang sudah kami capai, sama ada di dalam bidang akademik maupun aspek pembinaan sasiah insan. Seterusnya, menganugerahkan kepada kami kecemerlangan demi kecemerlangan. Ya Zajalali wal Ikram, kurniakanlah juga kepada kami kesihatan anggota, kecergasan minda, ketenangan jiwa, kekuatan semangat. Jauhilah kami daripada penyakit berbahaya, persekitaran dan hasad dengki. Semoga kami mampu mendepani cabaran, berdaya saing dan mampu mengangkat martabat diri, agama, bangsa dan negara. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Walhamdulillahirabbil alamin.
Thank you, Mr. Koyun, for the recitation of Dua. Ladies and gentlemen, moving on, I would like to welcome and invite Associate Prof. Dr. Wan Mazlina Wan Hussein for welcoming remarks and opening address. Thank you. Welcome.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Thank you everyone for being here. I am giving the opening speech on behalf of our pengarah, Professor Rosie. For this one, he can't make it this morning because he has a meeting with the KPT. So my apologies. He extends his sincerely apologies. Right. Assalamualaikum warahmatullahi wabarakatuh and Bismillahirrahmanirrahim. Thank you, Dr. Tay. Right, good morning everyone, Professor, Associate Professor, Doctor, esteemed speakers, and most importantly, the bright minds of the research group and research interest group members and postgraduate. Welcome to the much anticipated Futuristic Research, Energy, Environment, the acronym FREE Seminar 2023. On behalf of the directors, I am glad and happy to stand before you to kick off this exciting event as we come together to recognize and appreciate the outstanding achievement of our research group and research interest group for cluster energy environment members and postgraduate from academia. This seminar is aimed to establish close relationship and collaboration between the RG and the RIG energy and environment and in ReNeU. It is also to empower and engage researchers under the energy environment cluster, involve and empower the talent young of researchers for sustainability of UiTM energy and environment research. Encourage publications including scientific books in addition to index journals and proceeding. This morning, we are honored with the hard work of the Secretariat headed by Professor Madya Dr. Zareen Haryati, my colleague. And this morning, our morning will be enriched with the insights of the three esteemed speakers. Chemist Wan Mazlina Wan Hussein from SIRIM Berhad will share her valuable perspective on research, environment, sustainability management, life cycle assessment, a driving force behind sustainable business practices. Alhamdulillah, we hope her talk will shed light on the crucial intersections among environmental, industry and governance factors. Indeed, as we navigate an ever-changing global landscape, this talk inspires us to become socially responsible leaders of tomorrow. We are also indeed honored to have Mr. Zareen Khan, Abdul Jalil Khan and Dr. Roshnaliza Hassan from Malaysia Nuclear Agency. Both of them will share their expert subject matter on nuclear reactor technology and rare earth materials for green renewable energy applications, respectively. Their talks promise to be enlightening, offering us a glimpse in the cutting-edge research and innovations that define their research landscape. Ladies and gentlemen yang dihormati dan dikasihi, as we embark on these inspirations, the collective efforts of RG and RIG members and postgraduate committee members and distinguished guests, we continue to push the boundaries of knowledge and strive for excellence. May today events be a source of motivation, pride for all of us as we look forward to a future shaped by the brilliance and determinations of RG and IIG. Without further ado, thank you, and let the Futuristic Research Environment, Energy Environment Free Seminar 2023 commence. Thank you.
Thank you, Associate Professor Dr. Wan Liza. First of all, I would like to welcome our speaker, Chemist Wan Mazlina Wan Hussein, for her keynote speech entitled Championing Environmental Sustainability Performance Through Life Cycle Assessment. Let me share with you the background of Chemist Wan Mazlina Wan Hussein. She is the head of Environmental Management Section, Environmental Technology Research Center, SIRIM, Industrial Research, SIRIM Berhad. She started her career as a research officer with SIRIM in March 1995. She has been actively involved in life cycle assessment-based environmental sustainability projects since 2000. So her first experience in life cycle assessment project was initiated by leading a research grant project under MOSTI in 2002. In 2010, she was entrusted to spearhead the development of a national life cycle inventory database, Malaysian Life Cycle Inventory Database, MyLCID, a mandate given to SIRIM under the RMK9 development initiative to support sustainable consumption and production in Malaysia. Over the years of service, she also has been involved in negotiating, planning, leading, implementation various environmental sustainability performance assessment projects with both international and national level governmental and industry stakeholders. Her involvement in the life cycle assessment project, life cycle assessment-based product carbon footprint, and company-wide YBhg emission quantification consultancy and advisory and eco-labeling criteria development work covers multi-sectional entities, enable her to have a wide spectrum of understanding and perspective on the application of life cycles-based environmental performance assessment towards environmental sustainability strategies. Without further delay, please welcome Chemist Wan Mazlina Wan Hussein. The floor is yours.
Okay, never mind. I'll try with the mic first. Thank you. Thank you, Dr. Ate, for the nice introduction. Actually, I'm scared to be here because I know that, I'm facing audience of those that highly accomplished researchers. But of course, I take it as a platform for sharing. Okay, I haven't done my greetings yet. Thank you very much for UiTM for inviting SIRIM Berhad to this session. And a very good morning to all of you here, especially Yang Berbahagia Associate Professor Dr. Wan Liza, Yang Berbahagia Associate Professor Dr. Zaini. Yeah, look familiar before and I need to ask her name because I couldn't remember, maybe old age, catching up. Also to our distinguished speakers from Nuclear Malaysia, Mr. Zareen and also Dr. Rose Hasnoliza. Yeah, nice meeting you, knowing you. And also to all participants today, especially all those achieving doctorates or professor here. I'm glad to be here to share my thoughts, especially with regards to life cycle assessment application. Yeah, all right. Stop moving. Can I? All right. Oh, oops. Okay, basically, uh, I'm very near to the screen, so allow me just to stand here. Basically, my presentation outline were just giving you some overview about the global drive towards environmental sustainability. I will also talk a bit about life cycle assessment because that has been my core subject throughout my working life. And also we'll see how LCA is being applied in the current business scenario. And of course, I am sure you sort of having like, okay, so how does it go with the research part? Okay, never mind, bear with me because as I say, I'm from the industrial research, but to say I'm doing pure research, no. You can see from my slide also, I'm more into the application of the LCA into the business perspective. I started as a researcher, but since the team moves on, we see that my research part in LCA has become very minimal percentage of my entire work, because normally I will work with both industries and also research institution. So for industry is the bulk of the work. For research, collaboration with research institution, of course, we are supporting any research that has embedded environmental perspective in the research. You will see how important nowadays to have research that having preconceived way forward towards the environmental achievement. Yeah. So basically, talking about environment by pictures, when we have image, logos, or whatever, it's like automatically we are in the condition that we understand this is environmental related. Can see various logos here and there on the website, on the banners, everywhere, because of the environment concern that is rising throughout the world. And of course, when mentioned about the words itself, we heard of this sustainable development. Those days when I started in LCA, people keep saying go green, go green. So it's just about the same thing. And of course, driving sustainability. Now, people catching up with going towards carbon neutral, net zero, everything, right? Zero emission. And of course, the buzzword today, decarbonization. Whatever we do, think about decarbonization. So whether you are in research, of course research will lead to industrial application. This is the thing that we need to be, in sync with nowadays, yeah? So basically, if those days when we started, even when I started my career, I was actually tasked in environmental lab. I have had the experience analyzing wastewater those days when I started my career. But over the years, in Malaysia, the introduction of life cycle perspective, life cycle thinking, life cycle management has taken place way back in 2000. That's where we see the shift in our way of thinking. Those days we do environmental protection, as you can see on the slide, very, very traditionally, right? All this is the one that we are very familiar. Talking about environment, we always associated ourselves with the Department of Environment. That's how it goes those days. But now it's different. The catching up of environmental protection in terms of modern perspective, now you see all this work being sustainability and talking about policy principle also, our government becoming more aware of this push and pull factor. The society now, we are talking as the stakeholders. We are everybody as the society. We have to be proactive, and then it's all transboundary. It's international. So it's no longer within the local perspective or only for the national perspective. And of course, what I would like to highlight is here, the complete cross-media over the complete life cycle. No matter in what research we do, we have to look at the life cycle perspective of our work, of our system, because we don't want to shift burdens from whatever we do into the other phases of a system life cycle or a product life cycle or anything we can think about. Yeah? All right, so this is, I think, the common for people in the environmental management. This is the in thing that we need to understand. Of course, starting with the Sustainable Development Goal, and of course, there are 70 goals altogether to maintain the holistic healthiness of the environment, but basically related to life cycle principle, where I say not to shift burden in terms of the adverse impact to the environment, is actually goal 12 on the sustainable consumption and production. It's all related to all the societies, whether we are the user or whether we are the producer. And also, now it's very popular, and the trend around the world is because of the global warming. We are now looking at climate action to combat the adverse effect of global warming. So basically, we've seen Malaysia commitment from the SDG at the global level. We are committed, Malaysia is committed to the reduction of carbon intensity. We are looking into the clean technology. We are looking into the circular economy. And talking about circular economy, of course, you see, this is the life cycle perspective of things. So, in the World Economic Forum, they mentioned that the way we live now is actually we are using 60% more of the resources than we should be, actually. So we are actually impact in adverse way towards the environment. Biocapacity will be affected. So this is what we need to worry, because we cannot have two planets in the future. There's going to be no way about it that we're going to have two planets, right, to live on. And then, of course, current circular economy research and innovation, they are actually looking at the maximizing the resources and, of course, cutting off the carbon emission as much as possible. And shifting from SDG to circular economy now at the, I think, all institutions is actually looking at the environmental, social, and governance, right? I think even like a normal organization also, we are being pushed to have this embedded in our system. We have to embrace ESG. So basically talking about the environmental pillar of the ESG, we are looking at the emission management, energy management, water management, biodiversity, and also pollution. So I think all research around that we are embarking will have to have embedded into the environmental perspective of it. Okay, so I will just skip this because to see the relevancy to this platform today, I think I will just skip this. Okay, talking about life cycle principle or the life cycle assessment per se. As I mentioned, we are looking at the environmental performance. When I say product here, it's actually consists of anything. It could be product as goods, as process, as system, or as our own research in doing some specific subject matter. We can apply life cycle assessment towards our studies, because life cycle assessments is actually looking at the cradle to grave, where we look at the material extraction, production, use, and also end of life. So this is the life cycle thinking that we want to embed in our work, whether you are doing research or you are doing some industrial application. And then talking about life cycle assessment, the part that people of concerns is actually here, the impact categories. We see that the SDG, even our national aspiration, is actually to tackle climate change. But if we have a full perspective of life cycle assessment, it's actually about mitigating all the environmental impact. We are not skewed into one impact, but of course the current crisis is here, so most of people actually looking at this impact. But basically, for a more holistic approach, any research or activities should be handling all of all these impact categories. Yeah. Okay, so anybody familiar with the word carbon footprint? I think now I know that even my kids in school also know what is carbon footprint as a term, but maybe they don't know in depth. But sooner or later, we'll see that the same principle will be applied in terms of resource. At one time, we might be required to check on our resource consumption footprint. Also, I know it's picking up water footprint. So things on environmental perspective never stops there at the carbon. So for research entities, actually we have to be way advanced than other people. We are not reactive. When people say, okay, measure your carbon, we measure carbon. But for the research communities, we should be more advanced in our way of doing our research or activities, yeah? So I will skip this. This is maybe technical, but as I mentioned, it's actually the principle of cradle to grave. So if you are doing some research, you will need to know every phases of your research, the process or your product that you are inventing. So basically the idea is there. And then this is actually the final result or the output that people communicate with the other parties, your intended audience, why we are doing research, for what purpose. Similarly, in environmental perspective also, we need to communicate the environmental result. So this is just a sample in the business application. And talking about, because I know the concern even at the national level is also on the global warming to tackle the carbon emission and going towards decarbonization. A lot of activities now, of course, focusing on the carbon accounting. So when we say carbon accounting, it's actually life cycle assessment-based kind of evaluation, especially for the product carbon accounting. We are looking at the embodied carbon, and there are so many methodologies. I only listed here that is commonly used, but there are many more methodologies or standards being published to assist our work in assessing certain activities or certain process. And similarly also, at the company-wide level, not product specific, but at company-wide, we have to know our carbon footprint of all the activities occurring within the organization. And this just display of a result that normally being used or utilized by industries per se to highlight in terms of the environmental profile, so that from the environmental profile, any industries or even any research can tap on what is the problem there and how we solve the problem. That's the aim of it. So the result can be used to identify hotspot. It can be a problem statement that we in this academic research or industrial research, we need to tackle this. Yeah? And just illustration, the main point why I'm showing another part is on the organizational level to tackle the idea that the quantification, if we are doing carbon emission measurement, is not the same between product and also the organization. But the details, of course, those that go into depth of these standards or methodologies, they would know how to tackle things. But basically, the illustration of the results is important and how they are made use to our own goods. Yeah. Okay. I will come to the last part on the business application. You may see this also as your research application, because whatever research is doing is actually to support the business, right? The industry. We are not doing research for the sake of doing research, because I remember the first time I actually can call myself as a researcher when I did life cycle assessment for printed circuit board. That is my first research project. So looking at that particular small research for the E&E sector, just looking at the printed circuit board, there are thousands of things that can be improved further. Yeah, but of course we see those days we have products that are huge. Nowadays we see even from our handphone, it can do everything for us, right? You don't need a camera, you don't need a scanner, you don't need a fax machine. How technology involved is actually the way things are being how do I say, exploit for the benefit of the humankind, right? So that's how similarly LCA in the business application. So talking about LCA, whether we like it or not, I know when I was first introduced into LCA, I thought it is very academic. I thought, oh, this is good for the research entity. This is good for the people in the universities. No, indeed, it's not like that. It's actually, the application is for the business. We started as academic research, but in the end, it becomes very much important for the business application. As you can see here from the LCA application, it will actually have effect on the legislative development. I will share with you some of the example. It also have impact on the green procurement initiative of the countries, and of course through labeling for the product to make, to make a competitive edge for the product where people want to market their product based on the green perspective. So industries normally will be utilizing on the environmental labeling. And of course, as I mentioned earlier with regards to ESG, now even the public listed company and also SME, they are required to do their environmental footprint, which must mention the declared carbon emission associated with their business. Yeah. Okay, let's see on these a few examples that I extracted out, and for the sake of the audience, maybe you will appreciate it more. And yeah, talking about environmental labeling, I will not dwell into the detail, but basically when we say eco-label or eco-labeling, is actually governed by the ISO standards, and there are 3 of them. So basically, type 1 is the one that we see people claim as green label. So green label under ISO is considered as type 1 because it is third party verified or certified. Type 2 is also green label, but it is self-declared by the industries or by the businesses. Basically, we want to be wary at this type 2 because we don't want to end up being greenwashed. Of course, without compliance to ISO, we've seen a lot of products on the shelf. Actually, they are doing greenwashing by making claims, because we know under ISO requirement there are only specific claims that is there that industries can use or people can use. Any other claims, it is considered as greenwashing. Yeah. For example, in ISO, compostable is allowable, but when you mention the product is safe and environmental friendly, that is very much greenwashing. So we as consumer, we also do not want to be cheated with all this marketing being used without addressing actually the validity of it. But as we know, there are a lot, if you notice on the market shelf, people do claims that are not in line with the standards. So that's why this type 2 normally will see company that is very reliable, but when we see company reliable also, there are cases like Volvo, they are actually cheating the consumers also, right? So that's the thing. I mean, the integrity of businesses also, we as the consumer, just because they are very much reliable or popular, we thought they are okay. So as consumer, we need to be very much aware or educate ourselves in terms of the selection that we make. We have to have a prior informed. So at least we know what is it, and by having all this eco-labeling is actually to guide the customer not to be misled by all the claims. Yeah. And the third one is actually the one that very much related to life cycle assessment, because life cycle assessment is a quantitative assessment. So normally it is in the form of disclosure. Yeah. and they are actually can be verified and certified by third party as well. So these are the labels around the world, just to make you aware in case you have gone overseas also, or even Malaysia now, because Malaysia accepting all other green labels from other countries. So our market might be, flooded with products that are green products, but of course having a third party certified. So not only the locals, Malaysia one, there are also products, especially like maybe apology for not including the Singapore Green Lab mark, because quite a number of products in Malaysia actually having a Singapore Green mark, but this is just illustration purposes. And of course, talking about eco-labeling, for us in the country, we've seen a lot of this label, right? When we are buying our electrical appliances, and for some people, maybe you are very concerned with your water faucet, you might, shop for something that having this logo. And of course, for the rest, maybe you've seen carbon label and also green label that having the top mark, that is, of course, top mark is Malaysia mark, but operated by SIRIM, yeah? So basically, these are the labels, and even this YBhg label, I'm not sure what happened to the screen. It doesn't look hijau to me anymore, but it's okay, at least you get the picture. So this is the prior informed choices that we have as consumer if we want to exercise our environment, being a concerned citizens towards the environment. Yeah. And of course, as I mentioned, LCA application is actually having impact on the green government procurement in Malaysia. Malaysia has started in 2015, mandatory for all the ministries, and now I think all the government-related agencies. And of course, it will reach also, because of the ESG commitment, it will be a green public procurement and also green private procurement in the future. But in terms of green government procurement, we see that there are laws in different countries. That's why I say LCA application can also have impact because of the legislative development. But in most of the other countries, they make it like a voluntary initiative to go green in doing our procurement. And of course, the most for those in the business, or if you are dealing with industries, you know that especially industries in cement sector, iron and steel, aluminium, fertilizer, and then of course electricity not related much because we don't export our electricity to Europe. But of course, hydrogen precursor and all that we might have. All our, products sooner or later, because this is the transition for the prioritized sector. But in the future, this requirement will be expanded to other products as well. So basically, when people or other countries put in their policy or law on the carbon border adjustment, this is stand for carbon border adjustment mechanism, and also carbon tax, they are actually having the prescribed LCA based information. That's why I'm telling you in the beginning why LCA is the one that the principle that we need to embrace, because through LCA there will be requirement like carbon footprint just now, water footprint just now. So the fundamental principle is the one that we need to understand, and then we are more prepared to handle all the mushrooming legislative regulation that will affect our industries. So all this is actually legislative requirement to other countries as well, because for the global movement to achieve SDG, is not only enough we do it nationally. As I say, it's transboundary. So like people in Europe or the legislator in Europe, they don't want the leak or the less committed environmental activities in other countries coming back to their countries. So this is very much, of course, some party will say is strictly related. So whether we like it or not, it's strictly related. So for those who are doing research in all these sectors, I think this is one good point that you know is a problem here, and how we protect our industries to support their trade or their market in overseas, right? And of course, business impact from carbon disclosure, very specific, would be on the concern for our local industries, because now we have carbon trading or carbon market in Malaysia, right? Managed by the Bursa Malaysia. So before this, for companies, they do their evaluation in terms of environmental impact assessment, like for the single impact on carbon emission, they do their activities. Of course, there will be emission, but of course, as a continuous improvement, how they want to tackle or to be more environmentally friendly, especially in terms of carbon mitigation or decarbonization, they are looking into ways to decarbonize by reducing the emission. And of course, as I mentioned in in ESG requirement, companies now producing carbon footprint report within their sustainability report. And of course, for people in the research, these are the areas, especially project-based or novel invention. We need to look at all these potential carbon credits or GHG's project, meaning that the research of the project that you are working on can offer credit so that the businesses can offset their carbon emission through carbon credit worthy projects. Yeah. So this is my last slide. The key takeaways that I, as a person, or I would claim myself as LCA practitioner, for me, I see things that gets measured, get managed. So if we don't measure them, we cannot manage them. We cannot come up with something to solve the problem. So we need to get things measured. There are many ways. One of them, of course, through life cycle assessment or carbon measurement. In terms of the very in-demand environmental perspective currently. And another one is for we to be sustainable, we have to embrace environmental perspective. No matter how we like it or not, it's the time that we cannot say that this is market barrier, we don't want to go into this. No, it's the point that we stop having that perspective in this global environmental sustainability. And last but not least, I think I may be biased, but you may have your own way in look at things. But for me, I see life cycle thinking is the new business strategic thinking. It's how we survive in this environment now, where people are going towards a more environmentally sustainable development. So with that, I think I end my presentation, and thank you for your kind attention.
Thank you, Chemist Wan Mazlina Wan Hussein, for sharing her valuable knowledge regarding the LCA, which not only focus on research, however, is more on the application in industry and also for the public, for our living quality betterment. Now we move to the Q&A session from the floor. Any question from the floor? Any question from the floor? Anyone?
Hello, good morning. In SIRIM, if we have a software on counting the carbon or carbon credit, carbon sequestration, carbon footprints, is there any way that SIRIM can endorse that system and we can use that labeling for our business?
are various software offered everywhere. Nowadays, local, I would say local, but it's sometimes not actually local. It's Singaporean developed software. People now, from the IT research, they are actually doing software development to do this accounting. Talking about verification of the software for SIRIM, we don't care whatever software or tools that you use, or even you just use your spreadsheet. The important thing is we verify your work against the standards requirement. Yeah? So you can use the commercially available software, or you can develop your own software, but the fundamental behind the software must be in line with the ISO. Because for verification as certification to take place, you have to have a published document where you are doing your work based on. Because if we are doing our work, we are using a commercial software. The commercial software has its own compliance, but our work itself must tally with the methodology that we applied for, right? And even for because the different for SIRIM can offer verification, certification, and labeling. Verification is normally for what you say you are doing, then we verify. For certification, if you are extending further, for certification, that's where a specific standard or published document that we are in compliance to must be there. So that's the difference between verification and certification, right? Just now, doctor asked about verification. So it's okay. Whatever you are using, whether your own tool you develop yourself, or even if you use commercial tools to do this accounting, it can be verified. But you need to declare what you wish to comply against. That's the main thing. Yeah? Am I answering your question? Not quite. Uh-huh. Uh-huh. Yes. Mm-hmm. Mm-hmm. No standards. Yeah. Mm-hmm. Right. Okay. Okay. How it started is actually, there's a way to do that. First, of course, it is done at the research level, maybe, or the stakeholders into this area. But their idea, the quantification idea, to make it verifiable or certifiable, we need to propose for a new standard development. That's the mechanism. That's what we are doing in, SIRIM is accepting any proposal to develop standards from any industry, any institution. Because, for example, I'm giving you, we are looking at the higher level, ISO. But ISO is very generic. ISO don't tell us how to do things. ISO only gives us principle of how things should be looked at or handled. So it is our role is actually to develop not to say substandard, sorry, the wrong word, maybe a complementing standards. For example, in doing carbon footprint, ISO 14067 is there, but there is subsequent guidance document or standards on its own called the YBhg protocol. So the YBhg protocol is the stepwise how to do things. That's why if you use YBhg protocol, the verifiers or the verification body can verify you against the YBhg protocol. But in some cases, verification body can verify straight to the ISO, depending on the detailness of the ISO. It works like that. And talking about for the measurement of carbon stock in tree, I know that will be something we in SIRIM also actually promoting this development of standards, because SIRIM now is doing industrial standard. We don't do Malaysia standard. Malaysian standard is under Jabatan Standard Malaysia. SIRIM now reduced to doing industry standard. So it will be a good platform. People in this carbon stock measurement, as you mentioned, having three different way of measuring, maybe, I don't know. But a standard must be produced so that verification and certification can take place. That's how it is done. Yeah. So there is a way to do that. Not because it's not there, we cannot. But that is the way that we're supposed to follow. We have the idea, we propose the development because the country needs this value. The country needs this value because we have to see that currently all the projects that been taken place for carbon credit in Malaysia is actually projects from other countries. As simple as for us in Vietnam. But how come we in Malaysia don't have this kind of project? Of course, for research institution, and SIRIM also research institution, we are actually trying to work with anybody who have the same interest to support the, all these things is for the national good, right? So SIRIM having the standards department, but for industrial level standard, not Malaysia standard, yeah. Don't get mixed up now because suddenly SIRIM, those days, yes, we do Malaysian standard. But I think for the last couple of years, maybe 5 years or so, all the work has been taken back by the Standard Malaysia. So now SIRIM only doing industrial standard. So like we do for the eco-labeling, to get eco-label, we are actually producing a specific product category rules for, say, paint, for sewerage pipe. For all the products category, we try to develop the standard so that people can get their product verified, certified and labeled. That's how things work. So please, maybe now you know that we can do this, maybe put up the proposal, and it's our role actually to call up the working groups to work on this. And normally for industrial SIRIM industry standard, it takes less than 1 year. If we were to develop a Malaysian standard, I heard those days 2 years to complete. So this is a fast track to get things moving. Yeah, all right. I hope I'm clarified. Thank you.
Thank you for answering the questions. Okay. Okay, thank you, Ms. Wan Mazlina. Okay, now, much honor, we would like to call upon next honorable speaker, Mr. Zareen Khan, Abdul Jalil Khan, for his keynote speech entitled Introduction to Nuclear Reactor Technology. I briefly introduce to you our keynote speaker, Mr. Zareen. He is a research officer of Reactor Technology Division, Technical Support Division, Malaysian Nuclear Agency. He obtained his master degree in engineering and has a long service years of 21 years. His areas of expertise are reactor physics, nuclear engineering, and reactor instruments. Please welcome Mr. Zareen. The floor is yours.
Testing. Assalamualaikum and very good morning. And thank you for invitation to attend this kind of futuristic energy and environment. And I'd like to share my introduction to nuclear reactor technology, because currently I'm working in the Malaysian Nuclear Agency. We don't have any kind of nuclear technology, but we have a trigger type of reactor. That one is a small reactor, located in the Bangi. It's the maximum power is 1 megawatt. And that is a very small reactor. If you compare, I will share the biggest one as for nuclear as a clean energy, because we always prefer the clean energy. We need the zero emissions. That's why we need the option to nuclear energy. But currently, Malaysia didn't have any kind of nuclear energy. But in Bangi, we have only for research purpose of fission energy. It means from nuclear, we get the fission. But somehow, you have heard the fusion energy also. But there's a long way to come out for energy, new energy. Okay, this is the first slide. I will show the world's first nuclear reactor. It's an atomic pile in 1942. This one is the doing research in the Chicago University, led by the Enrico Fermi. It means they will discover the nuclear fissions. Okay, and as this is Enrico Fermi. This type is a graphite moderator type. This is the famous diagram of a first nuclear reactor in the world. It means the Enrico Fermi will measure the neutron measurements here. And this is the layer of uranium and graphite. Why are you using the uranium? Because the uranium is the most abundant. It's 500 times more than gold. It means we get a lot of uranium our Earth. It means even if we have uranium, we can find anywhere. Even our body also have uranium, small amount of uranium. And this is a first reactor, but in the top of, if it didn't that time, is not have any kind of instrumentation. It means they're doing by manually. It means they will insert by manually, going down the emergency rod. Emergency rod is about like they absorb the neutron. If anything happens, they will drop out. Okay, this is the world's first nuclear electricity generation in 1951. It means that only the 410 kilowatt, they're enough to light only the 4 bulbs. It means they're doing in the Idaho testing station. And this is experimental breeder technology. It means the first experiment technology before they're doing other things. And this is the first, it's like commercial in Russia, doing the first nuclear power plant. And this is a control room, and mostly in 1954, they're using the water-cooled reactor, graphite moderator. It's mean design capacity 30 megawatt thermal. It's mean the electricity only 5 megawatt electric. It's mean very small. Nowadays they have a bigger 1,000 megawatt electric. For example, in UAE they have four units. It means one unit can produce 1,000 megawatt electric. It means 4,000 megawatt electric. And they have an option for nuclear desalination also, not only for electricity but other purpose too. Okay, this is a versus. It means if you compare the nuclear and fossil, the fuel pellet is very small. It means equivalent to 1 ton of coal. 1 ton of coal. If you can imagine the small uranium pellet, it can be equivalent to 1 ton of coal and 120 gallon of oil and 70,000 cubic feet of natural gas. This is a very big energy for small uranium pellet. And all this is produced by US energy industry over the 60 years. It can feed the football field at the depth of less than 10 years. Okay, if how much power does the nuclear reactor produce? It means the equivalent 100 million LED and 431 utility scale wind turbine and photovoltaic panel. It means large or big amount we require if you're using for 1 gigawatt of power. Okay, how much land needed for 1 gigawatt electric? It means the typical 1 megawatt facility, for example, in the United States, is a little more than 1 square mile to operate. This means 1 gigawatt electric nuclear is required plus minus 727 football field. You can see the dimensions look like this. And if hydro is more than 4 times, it means its requirement. And if a solar and it's a 5,000, if a wind power is a 48,000. Why are you using the nuclear? Because the nuclear is a base load. It means we can operate continuously the power. It means 24/7. We can operate until 18 until 24 months without shutdown or anything. But the solar is like a peak load. It depends on peak. Yeah. And sometimes the solar is therefore not efficiency is less than 20%, but the nuclear is almost 35% efficiency of output power. But hydro is different, and wind is depend on the peak load. And this slide shows how the nuclear reactor evolutions. Mean we have generation 1, 2, 3, 3 plus, and 4. Now they already have this, but this one is currently they have a prototype, and maybe after 2030 they have. But the early prototype reactor is almost deployed, and the generation 2 is a 1960s actively safety system, and all 90% of currently operate is belong to generation 2, and this one is advanced light water reactor. It means to further passive safety system. It means that currently, like UAE, they have this kind of advanced light water reactor. And the 4th generation is still on drawing board or prototype, and maybe after 2030 they will implement. And okay. What is the technology is like early prototype. It means this type of prototype is so already some is decommissioning already, and it means some is like Fukushima from this kind of reactor, and currently most 90% is from large scale power stations here, and now they're currently in Japan. And this one is AP1000, mostly in the US and Korea. And they have also some small modular reactor. It's made very, not big power. It's made less than 700 megawatt. And this one is a revolutionary design. It's been gas-cooled fast reactor, molten salt reactor, sodium cool reactor, and supercritical water cool reactor, and very high temperature reactor. This one is so from 2017 they will project it. Okay, what's other, you can refer in the IEA Tech Doc, it's an International Atomic Energy Agency. There are a lot of information, this kind of reactor. It means a water cool reactor, including the gas cool, molten salt reactor, fast reactor, and the small modular reactor. Currently, it's a very famous because the small, not the bigger reactor, but the less than 700 megawatt electric, and there's like a very compact reactor. It's not easy, and basic system. It means anything happen, they will. By automatically will control by itself. No need to depend on human. Like a yearly prototype of reactor, they have some case of accident. But now the technology is more improved. They said don't depend on human or any kind of earthquake, seismic, whatever. they will automatically operate and shut down, cool shutdown. It means very safe to enter. What this slide shows the main reactor components. Mean in reactor, this is a containment building, and I will show later what's thickness. And the most important is fuel assembly. It means the fuel uranium structure material cladding tube to generate thermal energy and emit the neutron. Because the most important is here is emit the neutron. From neutron they will create the heat. And moderator, we need the moderator because the moderator usually we use the water, H2O. And the coolant to remove heat generated by the neutron fission, and control rod. Control rod is to control the change reaction. This means to withdraw the control rod to increase the fission reaction. The insert control rod reduce the fission reaction. The concrete shielding is the containment building is prevent the radiation and stray neutron escape from the core. This is a, I said previous slide, it means the fuel pellet is equivalent to 1 ton of coal power, the energy. This one, the fuel assembly, and currently the light water is a major for power reactor and as a moderator and coolant. How does the reactor work? It means the nuclear fission is work. It means the neutron collide with the uranium. With the nucleus of uranium atom, it become the unstable, split into the two small nuclei, 2 or 3 released from each uranium. It means from neutron interaction with uranium-235, it create 2 fission products. For example, krypton and barium plus 2 or 3 neutron and plus the kinetic energy is 200 MeV. That one is only for fission, per fission. But sometimes we have a lot of uranium inside of reactor core. That's why we call change reaction is happen. This is an example of interaction. The reaction should escalate the amount of energy released the enormous. It means a lot of energy is released. But for example, if a nuclear weapons or they have uncontrollable, we cannot control. But inside of nuclear reactor, we can control. It means we have a nuclear control rod. It means nuclear control rod. It means insert going down. It means absorb the neutron. It means can control. But in case of nuclear power plant, they only maintain the power for 24 months. It means long. It means 18 to 24, depend on the technologies, the nuclear power plant. And this is inside the reactor core, same like I said before this, the neutron interaction with the moderator, and going to slowing down with the fuel cladding and interaction with uranium, and we get the 3O2 neutron, and we get the fission energy heat. That's why I said we need the control rod to insert to absorb the excess neutron and control neutron flux. Okay, this is a slide show the what's the nuclear power plant look like this, and this is in the United States. This is a cooling tower, twin unit, and this is a control reactor containment building, twin unit and turbine, electrical switch yard, and grid connections like this. And this is look like the plant building. It's been the tower, it's been cooling tower, turbine building, and reactor containment building. Look like this. And this is most important for PWR, pressurizer water reactor. We call steam generator. This is a huge tube for like a heat exchange. It means the clean, immersed in clean water from the secondary loop, which is then turned to steam. Which means this device generates steam in the secondary loop is called steam generator. This is the biggest instrument inside of the containment building. Okay, this is from Steve. What we have the going to is mean going to high pressure turbine and low pressure turbine. This is the turbine look like this. Before that one, they have a low pressure, high pressure turbine. This is a low pressure turbine. And this is a core refueling. When after finish the operation, it's mid 18 months, they will refuel the core again. So this is the most common component in nuclear reactor. Okay, this is cooling tower, as I said previous. This is electricity. It's mean this one we call nuclear island. This part we call non-nuclear island. And you see this kind of design is PWR, pressurizer, because they have pressurizers here. If I will next slide, I will show the difference between other technology. And this is a steam generator. And the most important is a control rod and the reactor vessel, the pump, the condenser, the cooling water. Okay, this is the example of the technologies. AP1000 is mean the proven technology already implemented in many countries from Westinghouse, the company name. And this is a plan design and layout of Westinghouse. This is a component look like this. The number one is the fuel handling area, concrete shield building, steel containment building number 2. And this one is a 12 turbine generator. Okay, why using the nuclear fuel and control rod? Because I will show the next slide. From uranium array, we get the yellow cake powder and fuel pellet and fuel rod, and then go to fuel assembly. It's main nuclear fuel fabrication process. And this one is a type of fuel control rod. It's meant to control the absorbed neutron. This is for BWR, boiling water reactor, and this one is PWR, pressurizer water reactor, the 17 times 17 type. And uranium-235 has 2.5 million times more energy per pound than coal. It means 35 tons of fuel. It means 3% to enrichment per 1,000 megawatt electric per year. It means nuclear provide emission-free heat source that can be converted to multiple product, electricity, steam for industry done in Switzerland and Russia, Japan. And of course, some cases for future reactor, they're going to hydrogen production. This is currently for development, the technologies. Okay, I will show this one is for PWR, pressurizer water reactor. It's mean in the pressurizer, we must keep the pressure around 15.4 megapascal. And even though it reached temperature about the 300 degrees C, it's made the core outlet temperature around 3 to 5 degrees C. And this is a PWR look like this. And this is steam generator, this is a pressurizer. And this is a containment structure. The containment structure is the thick is almost 1 until 1.5 meter. Okay, the water is conducted in the steam generator and passed through the thousands of small pipes inside the, as I said, previous one, the pipe inside the steam generator. The heat in the pipe pushes the water in the steam generator to turn the steam. And the turbine power will generate, and which is turned to produce the electricity. And water reactor is pumped back into the reactor tank and heated again. And the steam from the turbine is cooled in the condenser, and is the result water sent back into the steam generator and heated again. This is a feed water temperature the outside from the we call the non-nuclear island. Okay, this is another BWR. It's another technology. They didn't have any kind of steam generator, but only the pressure vessel inside the reactor core. The pressure we have to maintain very small compared to PWR. The thick is almost the same on until 1.5 meter. The design for this kind of reactor is only for looping structure. No steam generator or pressure riser is inside. And water is circulate through the reactor vessel and convert to steam. The separator is installed to remove the water from the steam. And the steam travel into the main steam line to turbine, then through the condenser to be pumped back to core. This means the reactor control through the combination of control rod and changing water flow to adjust or minor adjustment. And then they use to remove heat if too much is produced, the thermal efficiency is greater than PWR. It's almost 35% of thermal efficiency. And not heat transfer is required between looping structure. It's less cost and require more maintenance, but it's not stable as PWR. That's a difference between BWR and BWR. Okay, what's the purpose kind of nuclear we can use for? For example, our reactor we call TRIGA. This means Training Research Isotope GA. GA is a company name, is a General Atomic. This is like a very small reactor and multi-purpose reactor and material testing reactor. This is only for purpose research, mostly for neutron production, neutron research. And specialized is for space propulsion. And the power, as I said, low water reactor, pH W reactor. It means the CANDU reactor. It means they're using heavy water, not like the normal water. And high temperature gas cool reactor. This one is a future technology. Maybe go for hydrogen production. And of course, we see the other kind of purpose. It's a submarine, navy, icebreaker, air carrier, and PWR cargo. And like other also they're using for tritium and plutonium. So okay, this slide shows how the fuel is fabricated. It's made from the uranium hexafluoride, UF6. It means they will convert into the uranium oxide powder and powder processing and pellet manufacturing into the fuel rod and fuel assembly. And after that, going to fuel assembly for reactor. It means only 1 centimeter around that. And this is look like the fuel. They will insert inside the grid assembly, the fuel tube. Okay, it's means the producing pure uranium dioxide from incoming uranium hexafluoride and producing high density accurately shaped ceramic uranium oxide pellet. And the fuel assembly, they have mainly from zirconium alloy and loading the fuel pellet into the fuel rod and seal and assemble the rod into the final fuel assembly structure. This slide shows the fuel cycle. We have open fuel cycle. It means they have 2 ons through the fuel cycle, single recycle. This is a normal and going to power station and spent fuel. But the spent fuel can interim storage. They will separate uranium to make MOX fuel. It's like uranium and plutonium fuel and going to fabrication and again going to power station. This is a open fuel cycle. And somehow everything have to go to high level radioactive disposal. It means the permanent disposal. We cannot maintain only in trim inside of the spent fuel. Mostly we can maintain almost 10 years only. After that we have to decide the permanent. Okay, this slide shows the nuclear waste management. This is a total waste. It means 3% is almost high level waste, 7% is intermediate level waste, and 90% is a low level waste. Where come from this kind of waste? It's mean from the nuclear power station. It's mean the extremely low level radioactivity, including the concrete, metal, and the other concentration of radioactive material. And high level radioactivity is including the control rod, reactor structure, and reprocessing plant. It means the high level radioactive waste, it means including the such as waste liquid. This is how the waste is disposed. It means the spent fuel is going to reprocessing or waste. I said previous slide, it's been mentioned look like this. And we'll glass tuning furnace, and we have strong stainless steel. And going deep, it means we're going deep. It look like this. The method of disposal, they are until 300 meter. It means deep level disposal is more than 300. This one is mainly for high level radioactive waste. It's only for nuclear fuel. That's why the high level is almost 3%. This is our reactor. We call trigger reactor. You're most welcome to visit our because we only using neutron for research purpose. And thank you very much. Any question, I will try to answer. Why? When? I'm not sure. Because currently we didn't look for nuclear energy. We have other kind of resources.
Because you compare with solar and hydrogen, and
Yes.
seems that nuclear is much better, right?
Yeah.
In terms of the waste management, environmental aspect. So why Malaysia didn't take nuclear as the main source of energy?
Yeah, but there's a policy decision making, most important.
Nuclear Malaysia has some inputs to the policy making with regards to the development of nuclear power or energy in
Yeah.
Malaysia. Does the nuclear have an input?
Yeah, because I think 5 years back we have a policy. It's not policy, but the option to nuclear energy. They have an economic transplantation program. But they have under Prime Minister Department, we have a company, Malaysian Nuclear Power Corporation. So last 3, 4, 5 years back, yeah. But now it already didn't have this company, already changed because government policy already changed.
Right.
Yeah.
Tuan, if because we are in university, can I ask what are the incentive or programs that the Nuclear Malaysia is doing currently in promoting the nuclear energy to the industry and also to the other stakeholders or consumers?
Yeah.
As you know, the electricity is the cost of electricity and management is rising. So yes, can we have some inputs on that? Thank you.
Yeah. But currently, Nuclear Malaysia is we didn't have any kind of policy. We cannot develop or canning, but we only for technologies, the nuclear technologies. We should wait for nuclear energy policy. That's the most important. But in terms of training, education, nuclear energy will provide to students the public acceptance is the most important.
Sorry for asking again.
Yeah.
We know that this nuclear is a green energy. We don't in operational we don't have any CO2
Yes.
combustion or what. Okay, but the most I believe and maybe you can clarify it. The most tricky of this is the cost of this from the material, the operational, and also disposing, and compared to conventional and renewable energy. Maybe you can share how much the price of it, of the generation, the price for generation of 1 kilowatt of nuclear energy compared to 1 kilowatt of electricity. Maybe that will clarify why we are not using this nuclear technology.
But I'm not sure the total cost of pricing, but in terms of construction, the price is more higher. But when operate almost 60 years or 80 years, the life cycle of plant, if we can maintain until 80 years, there's a much cost is lesser than others. Yeah.
We had Sweden, Japan,
Yes.
and also Germany, and we also have UAE. Why, in your opinion, on your experience, why is it they're going forward with nuclear for generating that? It can generate 3 main energies, right?
Yeah,
The
yeah.
one that you shared. Can you share with us?
Yeah, maybe their policy, they want to more options rather than only 2 or 3 options. It may not depend on solar or other renewable energy. They said want to go for nuclear too. They want to looking for other. Not only they're using the natural gas or coal power plant, but overall like to explore all kind of the technologies. Yes, for sure.
Sorry, I'm from law, so it's a bit different than the rest. How would you say, in your experience, the countries that adopted nuclear energy mitigate the challenges? I mean, for me, nuclear challenges is that it blows up easily, like you say, the fission. So how does these countries, when they decide to adopt, how do they mitigate the challenges? Thank you.
Yeah, mitigate the challenges is very tough. But yeah, maybe in future the country can go for, be looking for nuclear energy. Yeah.
One last question.
Yeah.
I have something to ask regarding the environmental view. Okay, from the management, we can see the GHG, of course, it will be an advantageous. How about the waste material and the water in the process of end of life cycle that maybe create another environmental impacts?
It's the impact to environmental.
Yeah, is it any assessment on the environmental doing on this part?
Yeah, they have an assessment. It's mean we have an environmental group. They will do the environmental assessment.
Okay.
But for mostly, I said my slide, the high level basis, we have to find out the final disposal.
Yes,
That's
because it's a long term.
Yeah, long term. That one long term.
Okay, thank you.
Yeah.
Okay, thank you, Mr. Khan.
Yeah.
Mr. Zareen, thank you. Okay. Okay, next we move to the next speaker, Dr. Rose Hasnoliza Hazan, Research Officer MTEG Group Industrial Technology Division, Malaysia Nuclear Agency. Her keynote speech entitled Rare Earth Element, Critical Material for Green and Renewable Energy Applications. Please welcome Dr.
Thank you, Dr. T, for the nice introduction. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang berbahagia Dr. Wan Liza, our today coordinator Dr. T, distinguished guests, ladies and gentlemen. First and foremost, thank you for inviting me to share my knowledge and some experience in this seminar, Futuristic Research of Energy and Environment, Free 2023. I have been honored today to deliver my speech titled Rare Earth Element, Critical Material for Green and Renewable Energy Application. I'm sure many of you today with a lot of excitement. Therefore, my objective today is to share and to provide satisfactory sharing knowledge and information by the time you leave the hall. Due to the time constraint, I shall begin now. So, my agenda for today, I will talk to you a little bit introduction to rare earth element, what is a rare earth application, and how the global energy crisis and environmental issues create or overcome the issues by rare earth element in application, and we go through the rare earth in renewable energy, and then we go a little bit briefly about general flow of rare earth extraction, and then we come to the issue and also problem and recommendation, and also the way forward in rare earth industry, and also the conclusion. So, what is the rare earth element actually? So, rare earth element is a series of chemical elements found in the earth crust that are vital to many modern technology. So, as we can see, the lanthanide consists of elements with atomic number 57 lanthanum up to 71 lutetium. In the periodic table, they are arranged in a row in what is known as the F block. Here. You can see from the lanthanide series, we have a lanthanum up to the lutetium with the added of the scandium and yttrium. It's about 17 elements inside the rare earth element. So this so-called rare earth element, because of the electron configuration of this element is defined by the filling of F block or electron subcell. So why we use rare earth element? So because rare earth element have a special chemical and physical properties, and then we can use various application in daily product and advanced scientific research, and also application in advanced green energy and technology became more significant in the recent years. So this is our periodic table. As you can see, some relate the rare earth element to the radioactive element. But bear in mind that the rare earth element is not radioactive. The radioactive element is from thorium and uranium here. So if you have clean rare earth element, so you don't need to about your health or anything, because this rare earth element is not so radioactive. So we'll move to the next slide. So here, as we can see, many applications that use rare earth in our life. For example, nowadays we have electric or hybrid car, battery, and also fuel cell, sensor, solar energy, and many more. So when this rare earth element arise, so since early 1990s, the demand for rare earth element has dramatically increased, and then it was forecast that rare earth supply would increase by about 5 to 6% So as I mentioned earlier, the demand in rare earth market today is about 1,200 metric ton per year. Why? Why? Because of this application that we need today in our life. So ladies and gentlemen, there seem to be hope that we are finally moving a blight slowly toward a more sustainable society. For example, solar panel, ban on the plastic, green building and more are increasing. Yet, no matter how green our reality may appear, we are still far away from being the environmental and renewable society we think we are becoming. Mostly, any rare earth element product is toward green technology. So what is green technology? So in Malaysia, if you ask me, I would say the green technology is a technology that does not harm the environment and the people itself. So today, we use fossil fuel. This fossil fuel will be burned and will get the greenhouse effect. So this idea, either you use rare earth element to change the problem in the global now, or find other alternative to reduce the crisis in the energy crisis. So that's why rare earth element comes in and comes to the idea to enhance the properties of the end user product. So, ladies and gentlemen, although I'm aware of the impact of the renewable energy, such as green and renewable energy to be the best alternative from the fossil fuel, renewable, I believe, are the lowest cost solution to decrease our huge environmental footprint, such as wind, solar, hydrogen, even geothermal, biomass, and hydrogen can be some solution to decrease our huge environmental footprint. So I think all of you agree with me that, as we know, Malaysia need our own renewable energy to make sure that we have overcome the energy crisis and also maintain and sustain our environmental health. So this clean energy sector has dramatic growth within the last few years, and with it has the demand for rare earth element as the crucial for producing green energy. And as you can see, as you look around, you can see and notice now how many roofs that have covered with solar panel, and more electric and hybrid car are driving on the street. So, but we are still lack in wind turbine for this green energy application. So all of this technology heavily depend on rare earth element. So for some example, rare earth element play an important role in almost every field of green energy. Neodymium is essential in the production of industrial permanent magnet, which are also an important part of the technology used in electric car. Modern photovoltaic system rely on rare earth, and there are even possibility to improve them even more with the use of rare earth element. Already there are no such way that we can neglect the rare earth element in our daily life. So, ladies and gentlemen, when you receive a call from your handphone, from your smartphone, it is neodymium and dysprosium that make your phone vibrate. So, the europium and the lanthanum are some of the rare earths that enable you to display on your smartphone screen and know who are you calling you. And then the SIRIM in the rare earth element is possible for your screen to be used and to be sustained for the next few years. Also, rare earth element also play an important key component for mobile phone, as we need almost every day today. As the rise of the internet, the blooming field of green energy from solar panel to wind turbine, and many other growing key industry have returned rare earth element into a hot commodity. I would say that in this 21st century, rare earth is something that we can call the goal of today's need. At present, rare earth elements such as neodymium and diprosium are mainly used in the permanent magnet of offshore of wind turbine. Why I say many type of magnet? Because magnet can be used widely in the wind turbine, in photovoltaic. That's why supermagnet produced from the rare earth element is important to us. So some of the example super magnet we use in every application. So, for example, in the medical equipment like MRI equipment, we need rare earth element to make laser for scientific and also industrial purpose, while the 5G networks is depending on the fiber dope with erbium. This erbium is another rare earth element. So that is where Malaysia can come in. As mentioned in the previous slide, the US Geological Survey estimate about 30,000 metric ton of rare earth ore in Peninsular Malaysia. It is good us to have the rare opportunity to make decisive step to master the knowledge surrounding our rare earth element. So about their rare earth application, their exploration, mining, and also their refinement. So now I take some example. What is rare earth do for this bulb and also this magnet? So as we can see, we want to save the energy in the electric bulb. So you use energy saving bulb. Nowadays you have a normal bulb and this one is energy saving bulb. With the same lumen, you need to consume 40% of the energy. But if you want to reduce the consumption of the energy, you need some rare earth inside that embedded in inside the bulb to reduce the energy by 60%. So in the developed country, you have no other option but use rare earth element to reduce your energy consumption. So another application or another example is the magnet that we use inside our motor. So this is our motor inside our car, and then this is a rotor. This rotor contain rare earth permanent magnet. That's why I said the magnet, permanent magnet from the rare earth element are very important, critical for the renewable energy or green energy. So if you put some magnet inside a coil, you can generate electricity to become a motor. However, when you turn it on, it becomes a generator. So with the aid of a rare earth element, it is 15 times stronger than the conventional magnet. It can be used in car, for instance. That is the function of the motor, and the motor is very small and unable to move at 100 km. If you will use a normal motor, you can imagine the size of your car that you drive is 15 times bigger, meaning that you need to consume more petrol. So using rare earth element indirectly reduce the waste from your car, therefore reducing fuel consumption in this example. So when we look about the rare earth industry, we come to the upstream, midstream, and also downstream. What is upstream? Upstream is more to the exploration and mining. Let's say we have open pit mining, and also we have in situ leaching, and so on. And then for the midstream industry, is do some hydrometallurgical and pyrometallurgical to crack and separate the rare earth element into individual element. So how about the downstream industry? The downstream industry that use rare earth element in the user end products such as our smartphone, solar panel, electric or hybrid car, and also permanent magnet produced from rare earth element. So this is example the hybrid car. So as you can see, the battery, lot of component inside the hybrid car use rare earth element to generate the car itself. For example, their motor and their battery. So if Malaysia can become an industrial heaven for rare earth industry, we will obtain technology for the betterment of our people. In addition, it will create employment opportunities for many Malaysians. As I can say that the growth of rare earth industry is only about 30 million ringgit Malaysia, while the hybrid car battery industry is going to grow to 4 billion ringgit Malaysia. I am talking about allowing Malaysia to have the opportunity to bring about a natural progression in the rare earth industry. So all the from the upstream, midstream, and downstream, we believe that we can generate more GDP to our nation. So other example is auto catalytic converter inside our car. This is auto catalytic converter actually inside our normal car, not the hybrid car. Normal car also have this converter. This converter, as you can see, it has a catalytic active material. This catalytic active material acts as a filter, and it contains SIRIM. SIRIM is one of the rare earth element, and this honeycomb structure have a catalyst structure that can enhance and do some reaction inside there to convert the what they say the emission of the CO2 gas. So as we can see, as we are far away from the rare earth industry and we going forward to this rare earth industry, we believe that the introduction to this auto catalytic and also end user product that use rare earth element can bring our back and bring some knowledge to be adopted in the renewable energy. The next idea to build a super magnet plant to create about 1,000 employment opportunities, and then some business model to produce a super magnet and can sell in-house or sell inside Malaysia or sell abroad. So some example, more example that I can give that I've some here is super magnet rare earth element. It is very crucial element and very important element that if you want to move to the renewable energy. So what is the rare earth element? So what we see here is our rare earth element. This rare earth element, you can see very high magnetization. So for supermagnet industry, we start from the mining and processing, and then we do some, before this we do some cracking and separation before we do the magnet production. And then after that, magnet fabrication, and then also the magnetic assembly up to the system integration. So what is a rare earth magnet? So rare earth magnet, we can say is a strong permanent magnet made from alloy of a rare earth element. This rare earth magnet are the strongest type of permanent magnet made producing significantly stronger magnetic field than other types such as ferrite or aluminium, nickel, cobalt magnet. So the magnetic field typically produced by rare earth magnet can exceed 1.2 Tesla, whereas the ferrite or ceramic magnet typically exhibit a field of 0.5 to 1 Tesla only. So for the rare earth magnet, we have two types. One is neodymium magnet and also samarium cobalt magnet. So these rare earth magnets are extremely brittle and also vulnerable to corrosion. So they are usually plated and coated to protect them from breaking, chipping or crumbling into powder. So as you can see, some of the magnet here are very shining. It's the coating material that prevent the magnet material from crumble to its powder. So the idea or the technology to produce supermagnet is highly recommended and need to overcome the energy crisis and to be adopted in the renewable energy. So how we transform this rare earth element into device that can be used for renewable energy. So individual rare earth elements do not occur in mineable concentration in the earth's crust, but are naturally mineralized together and must be chemically separated to use for technological application. That's why the rare earth element is rare. It becomes sometimes we call it a rare earth gang, and sometimes a rare earth mineral come together with the radioactive material such as thorium and uranium. So the mineral itself and also the technique to separate them, to separate the rare earth element into single element is very crucial and take very lot of steps. That's why it is called rare. So these rare earth elements have physical and chemical similarities, make them extremely difficult and costly to separate while generating a lot of waste. That's the issue in the rare earth processing plant. So the extraction and separation of rare earth element for technological application occur tremendously nowadays. But the technology for separating and extracting rare earth element is old enough. It's already 40 to 50 years old technology. So nothing new apply now, but somehow we manage to do some extraction and some cracking method to separate the rare earth element into individual element. So this is how we do the separating the single element rare earth element. So we start with the upstream industry from mining and extraction rare earth core. For Malaysian, this Basness site from Australia, and for Malaysia we have monazite and also xenotime that rich with rare earth element. And then the hot topic right now is IAC, ionic adsorption clay, that have very rich in rare earth element that have deposit inside Peninsula Malaysia, and many stakeholders come up with some proposal and some want to extract mining it out from our earth. So after the mining, we do some beneficiation of the mined rare earth ore. So this one we pick the highly concentrated mineral with the rare earth, and then we do separation for the rare earth oxide in the midstream industry. So we in Material Technology Group adhere to this one. We separate and we try to make the rare earth element into individual element. For the time being, we are focusing on the yttrium from xenotime, monazite. We extract lanthanum, SIRIM, and also neodymium. That's for kickstart for our team. As I can say, we start this research around 7 to 8 years ago. So after we do some separation, we will do the processing and refining. This is the purification part, so we can get rare earth metal and also the alloy. So after that, we go to the downstream. Either we want to go for the magnet or for other application. If you want to do solar panel here, solar panel, wind turbine, and anything that will be used for user will be in the downstream sector. So the output from the rare earth magnetic supply chain is the output. So I would say the magnet very crucial. We can say that magnet can be used in the electric vehicle motor and also in the wind turbine. Also many end user that need magnet in their use to enhance their property, enhance the product itself. So we come to the issue and some problem that rise into the rare earth industry. Some project inside the rare earth industry did not materialize because so much noise was made and people became frightened about the effect. This is about the public acceptance. Some say that the rare earth element is radioactive. We need something to make the people believe that the rare earth element is not radioactive. So some environmental issue and health problem, and then when we do some processing on rare earth element, we left behind huge waste such as very acidic environment and so on. And then from rare earth processing industry, locally we have some industry for upstream mining. For midstream industry, even we can say some top level industry were very active in this area, such as Linus Malaysia Corporation. This plant process the rare earth element, and then downstream industry we can do some our end products such as battery, magnet, and so on. So right now in Malaysia, I would say that we have a lack of rare earth element expertise. Even though in our part in midstream, to separate the element into individual is very hard and challenging. So what recommendation that I can give for this rare earth sector is we need to power our knowledge to know how to do it and try to increase our expertise in rare earth separation, and also the power of awareness. this is the public acceptance regarding the rare earth sector. So the rare earth element inside renewable energy or any other user, the public can accept it and use it without worrying regarding radiation and so on. So before I end my presentation, there's something we need to pound on this issue, that what are the education game plan for rare earth element? Where do we start? How it will work? And are we in Malaysia in the right track for the rare earth element industry? And then to see and touch is different from just knowing the theory. The theory we learn is quite simple, but when we go to the practical, it's very difficult and challenging. I end my presentation. So thank you. If any question arise.
Any question from the floor? Okay, I have a question to ask regarding the rare earth. Okay, for the rare earth, as we know, it increases the efficiency of the product. How about the environmental impact overall for the product improvement? Just like the LCA product from the A to B, and then we know the efficiency, how many percent it increased, and how many percent environmental impact it will decrease or increase. I think this should be tallied out for the future sustainable development.
So for my opinion regarding the environmental, if some company or stakeholder want to take action regarding this rare earth industry, we need some mitigation plan or some procedure SOP to make sure that anything that we are doing right now doesn't affect the environment. So for right now, JMG, Jabatan Mineral and Geoscience have developed SOP for the rare earth mining. That will be for perak to start with. So if the SOP is well and can go smoothly, maybe other state can follow perak state for rare earth mining. So that's one for upstream sector. For midstream sector, if we want to build some plant for rare earth processing plant, we need to take care the waste and everything to make sure the environment is not polluted. That's come in our lab. Even that other people said that it's the waste, but we recycle it, because in some rare earth industry, they said that the thorium will be the waste, but in our lab we recycle the thorium, we extract, and then we store it as another product. So we believe that if we apply very good knowledge regarding this matter, we can reduce the environmental pollution.
Thank you for the answer. Any question from the floor? Okay, since no question from the floor, so we will we thanks Dr. Lisa.
Okay, thank you for your attention.
Okay, let's move on. May I invite Associate Prof. Chemist Dr. Zaini Haryati kindly present a token of our appreciation to all the keynote speakers. Atas ke bawah foto? Bawah ke atas? Okay, firstly, we invite chemist Wan Mazlina Wan Hussein. Thank you. Second speaker, Zareen Khan, Abdul Jalil Khan. And our third speaker, Dr. Rose Hasnoliza Hazan. Thank you, Associate. Okay, I would like to invite all the speakers to take a photo with our Program Director, Dr. Zai. Okay, let us proceed. Everyone, and now we will go back. No need to stay. Duduk bawah. We will proceed to the photo session for all the participants and all the distinguished guests. I think can everyone move to this side, one side like easy. Speaker here. I will sit there. I will sit the second row. Okay, move to this side lah, easier to catch the crowd. Thank you, everyone. Okay, we will move to our next session, which is a parallel session. I would like to invite the first